Hey everyone, welcome back to the channel if you are returning, and welcome if you are new. So in the previous videos we have actually derived the velocity function using differential equations. Well, if you're not really a fan of calculus, then you might find that not really fun. But is there an alternative to it? Yes, there is an alternative to it, and we're gonna derive it using a bit of trigonometric identity, and this is by far, I guess, more simpler than using differential equation. So without further ado, let's get started. So we're gonna start by our x function. So we know we have an x function. Oops, that's too big. We have an x function that says a sine omega t plus phi. So for this particular video, just for this scenario, I'm just going to use sine, but you can use cos or negative sine or negative cos, up to you. But just for this video purpose, I'm just going to use sine as an example. Okay. Also, another thing to mention, in case you forgot or in case you are curious or wondering, so this phi part isn't really officially introduced in the A2 syllabus for Simple Harmonic Motion in Cambridge A level. But it's good to know because this phi is actually phase constant, and you learn this phase constant in AS in waves chapter. So don't be surprised if you see this in exam, but you can also just stick to writing a sine omega t. No problem, it's the same thing. Okay, for this video, I'm going to be using this function. Alright, okay. So now we have our x function. Next, we need to find what is our velocity function. So our velocity function would be, we differentiate the x function, right? Because dx dt is equals to v. Okay, I know this is a bit of calculus, but it's just a very tiny bit of differentiation. Okay, so it's not a lot. It's 1% and 0.001%. Okay, so dx dt equals to v, and this is the only differentiation part. Don't worry. After that, you will not see differentiation anywhere in this video. Alright, then, okay, so differentiate x function, you're going to get your v function. Okay, now, what will you get? You will get a omega cos omega t plus phi. I'm going to just put a big bracket there to make it more clear. Why is that so? Okay, so differentiate sine, you're going to get cos, right? And then if you differentiate the one, if you differentiate the one in the bracket, you're going to just get omega, so the omega is out here. Okay, if let's say you have a problem remembering differentiate sine, you get cos or what, here's something that I use. Okay, so I just draw an x, so this is sine, this is negative sine, this is cos, this is negative cos. So you go clockwise if it's differentiation, you go anti-clockwise if it's integration, because integration is antiderivative, right? So clockwise, differentiation. So differentiate sine, cos. Differentiate cos, negative sine. If let's say you want to know what happens if you integrate cos, you go the other way around. Integrate cos is sine, and integrate sine is negative cos. Okay, so this is something that I used to memorize, and I hope this helps you. Now that we have differentiated, step 1. Okay, what is our first step? Actually, this is our step 1 ideally. This is step 1, which is differentiating it. Now, what will be our step 2? Well, step 2 is, we're going to multiply the x function with omega. So what do I mean by that? So this is our x function, right? A sine omega t plus 5. I'm going to multiply this entire function by omega, and that would give me x omega. So I'm going to remove this t part in the bracket. It will mean the same. I'm just going to remove it so that it's easier to show you in the calculation. You're going to get a omega sine omega t plus 5. So I just remove this thing in the bracket. That's it. Nothing's going to change. And I just multiply omega to the x part and to this side, left and right hand side. Normal maths, you have done it before, right? Okay. And I'm going to label this as my first equation. Okay, simple as that. We're doing good. Then I'm going to label my velocity function. I'm just going to put a bracket here, okay? Velocity function. I have a habit of writing my cos like this. And it looks like W and S, you know. So I rewrite it again. Cos, okay, better. Phi and bracket. I'm going to label this as my second equation. So now, step 2 done. What are we going to do with step 3? So in step 3, we're actually going to square equation 1 and equation 2. After we square them, we're going to add them up together. So let's square them first. Okay, we do step by step. Let's square them first. So you square the first equation, you're going to get x squared omega squared equals to a squared omega squared sine omega t plus phi. That is our first equation squared. Then our second equation squared will give me v squared equals to a squared omega squared cos squared omega t plus phi. And close the bracket. Okay, now step 4. Okay. In step 4, okay, let's use a different color instead. Wait. Okay. Step 4 is where we add the first equation squared and the second equation squared together. So actually, honestly speaking, you can actually be straightforward with this method where you just straight away step 3 and step 4 you can combine them and you can just say first equation squared plus second equation squared straight away, so you can square them and add them straight away. I'm just doing here step by step for you to see it more clearly. Okay, and now adding the left hand side, you'll get x squared omega squared plus v squared, right? Okay. Then adding the right hand side, okay, and I just realized a mistake. This is supposed to be sine squared, and that is a different color. Wait. This is supposed to be sine squared. Yep, because you square the equation, right? Sorry for that. And now, coming back, now you add the right hand side, we're going to get a squared omega squared sine squared omega t plus phi plus a squared omega squared cos squared omega t plus phi. So, well, we can actually do something here. We can actually factorize a squared omega squared out. So, if I rewrite this again, I'm going to get a squared omega squared sine squared omega t plus phi plus cos squared omega t plus phi. Okay, now this is where the trigo identity comes in. Does this seem familiar? Okay, not the whole thing. I mean the one in the bracket. I think you might be really familiar with it because we know sine square x plus cos square x gives you 1. And this is an identity. Alright, it's just the difference is your x is now omega t plus phi. So this whole thing now becomes 1. So let me rewrite this. You will get x squared omega squared plus v squared a squared omega squared. Because the whole thing in the bracket becomes 1, so this is what you get. Now we're going to find the velocity function. Am I right? Okay, so let's make the velocity as our subject. So a squared omega squared minus x squared omega squared. As usual, you can factorize the omega squared out, like terms. You're going to a squared minus x squared. We're getting really close. Now, we're going to make v solely as the subject. So, plus minus square root omega squared a squared minus x squared, and this will give you the velocity function. And there you go. Very simple way to derive, right? We just use one simple trigonometric identity and the rest is just more to manipulating the equation. And you finally got your answer. Much better than differential equation, right? Yep. definitely much better. And also I think the lengthwise, I think both have the same, almost the same length, but it's actually your preference. Some prefer using calculus mode, some prefer using trigonometric, but of course using Trigo is even more easier. And yep, so that's all for today's video. I hope you learned something new today. It is another different way to derive velocity function, but there's always an alternative, right? Yep, so that's all for me today. I hope this video really helps you, and I'll see you in the next video. Bye bye.